talking, please? Thank you. I appreciate that. Today, let's start by taking questions from the previous homework assignments from Chapter 3. Megan Tompkins? Well, we didn't ask you to do 7 or 8 yet, so that's probably why you weren't sure what to do with them. So that's actually on the agenda for today. Sure. Let me type this in real quick so we have some semblance of what this page is. Okay. So number 5, we're given this function. And we're asked to find the period or the amplitude, period, and frequency of the function and graph it on the interval from -4 to +4. Okay? So I would first start by rewriting this in the form a times sine of 1 over b times x minus h plus k, so that I can identify the a, b, h, and k, because those are critical for me both in generating the points for one period of my graph and also for identifying the amplitude, period, etc. So hopefully it's not too hard to see that the a is 2, that the b is 2, and the h is 0, and the k is 0. You good with that? Okay. I know the amplitude is the absolute value of a, so that's just 2. The period is 2 pi times the absolute value of b, so that's going to be 4 pi. And the frequency is 1 over the period, so that's 1 over 4 pi. So far, so good? Okay. Now I'm going to take my key points for sine. So we talked about these in the notes yesterday. Or not yesterday, we didn't have class yesterday, but you know what I meant. And I'm going to use the radian versions for the angles because it's asking me to graph from 0 or from -4 pi to +4 pi. So I want the radian measures anyways. And I'm going to write my transformation map. Which is this. So really in our case, we just have 2x comma 2y, right? Okay. So this first point stays where it is. And this becomes pi comma 2. And then 2 pi comma 0. And then 3 pi comma -2. And 4 pi comma 0. Does that feel okay there so far, Megan? Okay. Now I'm just going to plot this. And for me, what I'm going to do is I'm going to steal some good graph paper so that I can graph this nicely. Okay. So I have 0, 0. And I have 1 pi 2, 2 pi 0, 3 pi -2, and 4 pi 0. So that's half of what I need to graph, right? Now I'm just going to extend this in the other direction. So I'm going to have -pi -2, -2 pi 0, -3 pi +2, and -4 pi 0. And then I'll just finish kind of drawing things out. Is that okay there, Megan?
Yeah. So when it comes to graph and intervals, like whatever, you just have to do that on the x-axis.
Right. So that's just telling you basically how many periods to do. Yes, so just do one period's worth, because you know the other one is going to be like basically the same spot. You're just extending it in the other direction. So you don't have to generate those points. All you have to do is plot. Does that feel okay? Okay. These are good questions. I like the specifics of like, okay, how do I do this and what do I really need to do this? Because yes, you could generate the points for all those things, but like you don't need to. You can just plot them because you know where they're going to be at from that point. Just kind of following the pattern. Who else has questions from the assignment? Oh no, I should. Is this Elizabeth Housey? Yeah. Okay. 12 from the book? Yes? Okay. I couldn't remember on the worksheet what numbers it went up to, but I didn't think it was 12. But okay, so similar question. It's just asking us to graph on the interval. The interval here is a smaller interval, but that's fine because it'll probably be the same kind of extension here. So I'm going to start the same way I did before, where I'm going to identify the values for A, B, H, and K. So hopefully it's easy to see these values. Elizabeth, do you need any clarification on how we got any of those? Okay, if you change your mind, let me know. Okay, and we can certainly go through it, but I don't want to waste your time if you're good with it. So now we'll draw our write our transformation map. So again, it's bx plus h, and then ay plus k. And because this is a sine function, I'm going to use the 5 key points for sine. So these are the same key points that we just used because that was also a sine function, and this is also a sine function. So far, so good? Okay. So 0 plus pi over 4 is pi over 4. And then 0 times a half plus 1 is 1. Pi over 2 plus pi over 4 gives me 3/4 pi. And then a half plus 1 is 1.5. And since we're graphing, I don't see any reason why I can't convert that into a decimal. Everybody's okay with that? Instead of writing 3 over 2, I'll just write 1.5. 1 pi plus 4 pi is 5 pi over 4. And then 0 times a half plus 1 is 1. 3 halves plus a quarter is 7/4. And then negative a half plus 1 is positive a half. And then 2 pi plus 1/4 pi is 9 pi over 4. And then 0 times a half plus 1 is 1. Okay with that so far, Elizabeth? Okay. If you change your mind, please speak up. Sorry, I'm just fighting with this thing, trying to get me the axis I'm looking for. I guess that's as good as it's going to want to do for me. That's fine. We can squeeze that last one in there. Okay. So again, I've just drawn in my axis. So we start at pi over 4 and 1. And then we have 3 pi over 4 and 1.5. And then we have 7 pi over 4, or I'm sorry, 5 pi over 4 and 1. And then 7 pi over 4 and a half. And then 9 pi over 4 and 1. Okay with that so far? Okay. So if you look, it's basically every half a pi, we're getting another point. So if I back up, this is a midline point, so I should have my low point there. And then back to my midline, and then a high point, and then back to the midline, and then another low point. So that should be what my graph kind of looks like. Is that okay, Elizabeth? Okay. So again, if you looked at the worksheet, if you've looked at that yet, that'll be kind of the format that the test will have questions like the graphing on, where I kind of make a grid on there already for you, and I have the axes labeled rather intelligently for you, and it's usually pretty straightforward on where the points go. So it's a little bit easier, I think, to do than trying to draw it by hand, where you're trying to figure out what the heck even labels should I have in my x and y axes. Megan?
For that one, was the interval
Yes.
why would you do 9 pi over 4?
Well, just because I've at least graphed past 2 pi, I just needed to figure out, like,
Oh, like it's okay to draw that.
yeah, for sure. I just wanted to know, like, what to do with that little part.
Okay.
So the easiest thing to do is just do the next point after it, and then you've got at least 2 pi. Does that feel okay?
Yeah.
Good questions, though. So it's always okay to do a little more, right? Just can't do less. Because if you give me more, it's like, okay, I got the part that I wanted. Extra is fine. You can do extra. Do as much as you want. You know what I mean? No big deal. What do you guys think? Is that okay? Okay. Anybody else with questions that you want to talk about before we move forward? We're just baby stepping forward. We're going to work on one skill today. I'll do a couple of examples, and I'm going to give you time in class to work on stuff. Because quite frankly, some of these things are kind of tricky, and I think it helps to have a chance to ask some questions and collaborate a little bit more together, or just have time to sit and think on your own if you're a lone person. Some of us do better by ourselves than we do talking to somebody else, and that's fine. No big deal. Okay. So what we're going to talk about today, we're still in section 3.1. And here we're going to go from, the idea is we're going to go from a graph or information about the graph to a function. Okay, so Megan, this is pretty specifically related to like 7 and 8 from the homework set, which was asking you basically to do the same thing, right? So let's look at an example here. And the example that I'm going to pull from is exactly this example in the lesson. So I'm just going to do a little cut and paste job here if it's going to cooperate with me. Boy, that's little. Boy, that's as clear as that came through. I'm disappointed. Oh well. I will translate. Okay. So, in order to write this, let's say we're going to write this as a sine function. And then we'll do the same graph, but we'll write as a cosine function, because for any of these you could do either one. And then we'll talk about like when is it best to use one versus the other, because sometimes one will be easier than the other. But until we try to do both, it kind of makes it pointless to try to explain to you when you want to do one versus the other, because you won't understand like the drawback of choosing one versus the other, because you can always do both. Is everybody okay with that plan? So for me to write this, I need to figure out what A, B, H, and K are, right? If I can find the values for those, it should be pretty easy. Everybody's okay with that plan? All right. So the things that I'm going to use to do this is I'm going to remember that the amplitude is the absolute value of A. So where on the graph is my amplitude? Well, remember the amplitude is like the distance. Well, we should probably say it's like half the distance from a maximum to minimum, right? So that amplitude is going to be half that distance. Okay with that? So what does that distance appear to be? The distance appears to be 4. Half of that distance is 2. So we can say that A is either 2 or -2. We're not sure yet. We'll figure that out in a moment. Is everybody okay with that idea? Okay. To figure out the K, remember that the midline is y equals K. So where's the midline on this graph? Yeah, it looks like it's just the x-axis, right? So there we know K is 0 right away. Is everybody okay there? Feel good? So far, so good? Okay. The next one we should find is the B. To do that, we're going to remember that the period is equal to 2 pi times the absolute value of B. So my period, what's my period going to be in this case? Well, it's going to be here all the way to here. It's the length of one non-repeating segment of or cycle of the graph, right? So that's going from -2 pi down there to +2 pi down there. So my period should be 4 pi. Is everybody okay with that idea? So if the period is 4 pi, I know that the absolute value of B then is 2. So either b equals 2 or b equals negative 2. Everybody okay there? All right. So now it's time to make some decisions about whether we should make these a's and b's positive or negative, and to figure out the h as a result. Okay? So this is the tricky part, is that you can get an equivalent answer depending on your choices here. So there's a way to pick a to be negative and get the correct answer. There's a way to pick a to be positive and get the correct answer. There's a way to pick b to be positive and get the correct answer, and b to be negative to get the correct answer. The h will be different in those cases, but any of them can still result in a correct answer. Okay with that? The idea here is I want to make things as simple as possible. So when I think about the parent function for sine, it looks like this, right? What do you, if I compare that to what I have above, what do you notice has happened? It's flipped. What way? You could think about it as flipped over the x-axis, or you could think about it as flipped over the y-axis, but it can't be flipped across both, right? Is everybody okay with that? So we're going to pick either A or B to be negative, but not both. In general, since we have the choice, pick B to be positive. It makes life much, much easier. So we're going to pick A to be negative and B to be positive. Do you have to do that? No, but it makes finding the H a little bit easier in some cases if the B is positive. Is everybody okay with that? Okay. So we know what we know A, K, and B already, correct? So what I'm going to do is I'm going to find some point on my midline. Actually, I wanted this still. I'm going to refer to this again. So I could pick this one, I could pick this one, or I could pick this one. It doesn't really matter. But if you have our choice, which one of these points should be the easiest one to use? 0, 0, because both the coordinates are 0. It makes the arithmetic pretty trivial. Everybody okay with that? Now, what I'm going to do is I notice that here on my graph, the parent function is also at the point 0, 0. Everybody agree with that? So we know xy goes to bx plus h, ay plus k. So here we're going to take our point 0, 0, and we're going to map it to this point 0, 0. If that's the case, if we fill in our values, b was 2, a was negative 2, and k was 0, what does h have to be for 2x, or I should say 2 times 0 plus h has to give me 0? Or this is this 0, and this is this 0? Well, h has to be 0, right? So there was no right or left translation, which shouldn't be surprising because we considered the parent function also had this point 0, 0. Let's just, for the sake of argument, say we had chosen this point instead. Okay? So here we would have been considering 0, 0 being mapped to the point 2 pi comma 0. So again, what I would say is using bx plus h. So I would say 2 times 0 plus h should give me 2 pi. right? That's how I transform this coordinate into this coordinate. So what would that tell me is h is equal to 2 pi. So that's an acceptable answer. If you would have picked the other point and done negative 2 pi 0, you would have gotten that h is negative 2 pi. That's an okay answer. Those are all acceptable answers. But let's use that h is equal to 0 because it's the simplest one, right? So if I take this now and put everything together, I have y equals negative 2 sine of 1 over 2 times x minus 0 plus 0. Now you could simplify that down if you wanted to, or you can leave the zeros and stuff in. Either is fine with me. But for the notes, I like to leave them in so it's obvious for you guys to see what it, how we put everything together. And I wrote that way too big because I'm going to do the cosine right next to it in the other column here. So let me write that a little bit more respectably sized. Are we okay with what we did there? We're going to do some more examples. So if you're not like 100% sure, especially at the h stuff at the end, we're going to do some more examples and it'll get a little easier. Okay? All right. So let's say we're going to do this same picture, but we're going to do it as a cosine function. Does the amplitude change at all? How we found the amplitude if we're considering this as a cosine function? No, right? So we'd find a the same way. It's either 2 or negative 2. Does the midline change at all if it's a cosine function? No. So we'd find k the same way. K is still 0. Does the period change at all if we're considering a cosine function? No. So b stays the same. Here's the part that's going to be different, though, is finding h. Because remember, our parent function for cosine looks like this. So I'm going to choose to use this point for my cosine function, which is the point 0, 1. And I'm going to map it to, notice that this point here is a maximum on my parent function. Does everybody see that? So what point from this transformation should I pick? I should also pick its maximum. Is everybody okay there? By choosing that as a maximum, I need to fix a to be positive, and we said we're going to always choose b to be positive. Why is a positive there? If I'm starting with a maximum in my parent function, and I'm mapping to a maximum in my transformation function, there was no flip that could have happened there, right? If I instead had chosen to go to this point down here, then I would fix a to be negative, and that would be fine also. So what are we doing here? We're taking the point 0, 1, and we're mapping it to this point, which is negative pi, comma 2. Well, I know that bx plus h should give us negative pi. In our case, b was 2, x is 0, and h is what we're solving for. So it should be easy to see that h is negative pi. So we can say y equals 2 cosine of 1 over 2 x plus pi plus 0. everybody okay there? Let's do some more examples, right? Because I don't expect one example to be good on something like this. This is kind of tricky. But 3/4 of it is pretty easy to get, right? We're just looking at the picture and reading off values for like the amplitude and the period and all that stuff, right? That part's usually not too hard. It's getting the h at the end that's sometimes kind of tricky. Let's do that. Another example. What if I just zoom in a lot, if the resolution will be any better? Not particularly. Okay. So we've demonstrated that we can do sine or cosine for either one, right? Everybody agree with that? If you have the choice, this is how I would choose. I would choose by what's intersecting the y-axis. So if the y-axis is being passed through at a maximum or a minimum, I would use a cosine function. If it's being passed through at its midline, I would use a sine function. The reason I can do that, the reason I'd want to do that is because immediately I know the h is 0. Right? Because the cosine starts at a maximum, or if the a is negative, would be a minimum. So there's no translation right or left necessary, so the h would be 0 immediately. Or for a sine function, it starts at a midline point and then goes maximum, minimum. Even if it starts at the midline point and goes minimum and then maximum, that's fine. The a would be negative and the h can still be 0. So that's what I would look for first if I'm going to choose to do one or the other. Now keep in mind they can always both be done. It just makes life easier if you don't have to find h. If you immediately can look at the graph and go, oh, h is 0. Because that's usually the trickiest one to find. So let's say that we're going to do this as a cosine function. And I know that h equals 0 because we start at an extrema. Everybody okay with that notion? All right. What's the amplitude in this case? 1. Everybody okay with that? The distance from here to here is 2, so the amplitude is half of that. Peter? Nope. Daniel?
So you said like y is
So if we think about the parent function for cosine, the parent function looks like this. It starts at a maximum on the y-axis. Ours starts at a maximum on the y-axis. So we can think of nothing being shifted left or right. We're going to think about it starting right with no shift left or right at all. If it started at a minimum, we could still fix h to be 0 and just think about a reflection happening with no shift left or right. So if I have a maximum or minimum on the y-axis, I can use cosine function with an h0. If I have a midline point on the y-axis, I can use a sine function where h is 0. Okay with that idea? Okay. And we're good with the amplitude being 1 or -1. Can it actually be -1 though? We know it's not because the extrema we have here is a maximum. So we know that it must be a positive one. If the extrema that we started with was a minimum, then we would know that the A had to be negative 1. Is everybody okay with that idea? Okie dokie. Let's find the K now. To find the K, we're going to look at the midline, right? Where is the midline? 1. So that tells us that K is 1. So we have H, A, and K. Oops. I don't mean amplitude, I just mean A. So the period is the last thing we need to find because we know that's related to B. So I'm just going to go from like a maximum or minimum to the next maximum or minimum. I didn't do it that way on the previous one because I had only one maximum and one minimum to look at. So I had to go like, make sure I had a full up and a full down. Here I have lots of ups and downs though. So I think the easiest thing would just to be like, to look at that distance. Is everybody okay there? But there's lots of ways to find that period. There's lots of periods on here to choose from. But say, for example, that's one. So from 1 pi to 3/4 pi, or sorry, from a half pi to 3/4 pi, it's just 1 pi. I know it's hard to read the tick marks there because the resolution on this picture isn't very good, but that's what's going on. So the period is equal to 2 pi times b. If I divide both sides by 2 pi, I get that b is 1/2. Oops. Or negative 1/2. For a cosine function, does it matter if the b is positive or negative? Remember, the b value is going to do a reflection across the y-axis. For this, if we reflected across the y-axis, would you be able to tell the difference? It would be the same thing, right? So it doesn't really matter here in this case, but we're just going to always pick b to be positive anyways. And now we have everything we needed, right? And again, you could simplify this down if you wanted to just call it cosine of 2x plus 1, and that would be fine. But again, on the notes, I'm going to write it in without simplifying anything, so it's easy to see where how I plugged things in. Is that okay? All right, let's do some of the word ones. So it's the same problem, but instead of giving you the graph, we're going to just give you some information. So this problem says construct a sinusoid with an amplitude of 4, a period of 3 pi, and passes through the point 3,1. So if we know the amplitude is 4, what does that tell us right away? Or negative 4. We're not sure which. Is everybody okay with that? We'll figure out which in a second. The period is 3 pi, so we can use that to figure out our value for b. So if I divide both sides by 2 pi, I get that b is 3 over 2, or negative 3 over 2. Everybody's okay there? And now the question becomes, what do I do with this point? Because somehow this has got to give me h and k, right? Well, let's make life as easy as possible. So this is my point 3, 1, right? Where on my sinusoid is that point going to fall that gives me the most information? If it's a midline point, is the best case scenario. So if that's actually a midline point, it's going to tell me the most. Because immediately it tells me it's a K. I'm just going to abbreviate MLP as midline point. So immediately after I've done that, I know that the K is 1. For either sine or cosine. And if we use a sine function, h would have to be 3. Is everybody okay with that? If we use a cosine function here, now life gets a little bit more difficult, but not so bad. So we know the point 0, 1 needs to turn into the point 3, 1. So to do that, we need b times 0 plus h has to give us 3. Or again, okay. So there's that, So the other option would be assume that 3, 1 is equal to an extrema. If we pick a maximum, a would have to be negative. If we picked it to be a minimum, a maximum, a has to be positive. If it's a minimum, a would have to be negative. And then if we use a cosine function, we can again say h is equal to 3. So for a final answer, one acceptable one could be y equals 4 times sine 1 over 3 over 2 x minus 3 plus 1. Or if you wanted to do a cosine function, 4 times cosine 1 over 3 over 2 x minus 3 plus 1. This is the easiest situation when you're not specified where that point needs to be located. If we don't know that that extra point has to be a maximum or a minimum or on the midline, you can choose to put it wherever you want on your graph. So you have a lot of freedom to kind of make the problem as easy as you possibly can. Let's look at an example where you don't have as much freedom. So this one says, construct a sinusoid that has a minimum value at 510 and a maximum value at 532. So I'm going to start by kind of drawing a picture to get an idea of what's going on, because maybe it's not entirely clear what's going on or what I should be doing or what even this looks like. So maybe 510 is here and 1532 is here. We're told that that point's a minimum and this point is a maximum. So we know this is kind of what we know about, right? Everybody agree with that? Okay. So two pieces of information are immediately available to us based on this picture. We know that the midline is halfway in between the maximum and minimum, right? Everybody agree with that? So K is going to equal the maximum y-coordinate minus the minimum y-coordinate divided by 2. Oh, sorry, plus. You guys are good with y, it's a plus? Clearly 11 isn't halfway in between 10 and 32, right? We want the average value. We have to add them. Remember, the k, or the midline, was the average value for the function. That was the verbal definition. So we're just taking the average of these two y-coordinates. Is that okay? The amplitude is half the distance between them. So that's where we're going to be subtracting. Is everybody okay with that? Okay. So from here to here, how much of a period is that? It's not a whole cycle, right? How much of a cycle is it? It's half a cycle, right? 1/2 the period is equal to the difference between the x's. Okay with that. So I have 1/2 times 2 pi absolute value b is equal to 10. Is everybody okay with how I wrote that? Well, 1/2 times 2 is just 1. So I have just pi times the absolute value of b. So b is 10 over pi, or negative 10 over pi. But we've already said that we're always going to choose the b to be positive. I would do that in this case as well. So far, so good. Now we should pick whether we want to do a sine or a cosine function, because that'll have a big impact of how we find the h. If we're given information about the maximum, minimum, which one should I choose? I should pick a cosine function. Does everybody agree with that? Okay. So since we're going to pick cosine, So if we use the minimum, our a should be negative. And if we use the maximum, a should be positive. Let's just use the maximum. Since we have one of each, let's just pick to use the maximum. Sound good? Is that okay? So we're going to take 0, 1. That's the maximum from the parent function. And we're going to send it to 15, comma 32. That's the maximum in the transform function. So again, what are we saying here? It says b plus h has to give us 15. So just h is equal to 15. So if I put it all together, that's what I got. Yes? Yeah. I'm just writing it this way in the notes so it's clear how I got things and where I plug things in at. But yes, feel free to simplify anything down to make your life a little bit easier, make things look neater. Absolutely do that. No problem at all. And Dan, even if you want to distribute the pi over 10 through, that's even fine. You know, like it simplifies a little bit with the 15. But this is still fine for me. You don't have to do any more simplifying than that. But you can, certainly. Okay, we're going to stop here.